where is that term? Modulus of Rn of z minus Rn of w divided by z minus w. What will happen to that term? You know that Rn of z minus Rn of w is this, and you convert this terms, and this term is less than or equal to k r raised to k minus 1. So what will happen to this summation? What will happen? This term is less than or equal to k r raised to k minus 1. So what will happen to this summation? So this is less than or equal to, modulus of Rn of z minus Rn of w less than or equal to which term? 1 by z minus w sigma k is equal to n plus 1 to infinity. K is equal to n plus 1 to infinity. ak ഇതിനെ നമ്മൾ മാറ്റി അല്ലേ, z raised to k മൈനസ് ഇതിനെ നമ്മൾ മാറ്റി. അപ്പോൾ ഇതെന്തായിട്ട് മാറി? മോഡുലസ് ഓഫ് Rn of z minus Rn of w is equal to sigma k is equal to n plus മോഡ് എടുത്തിട്ടുണ്ട് അല്ലേ, മോഡുലസ് ഓക്കെ z minus w. അപ്പോൾ സിഗ്മ k is equal to less than or equal to sigma k is equal to n plus 1 to infinity mod ak, mod എടുത്തുകൊണ്ട് mod ak less than or equal to this mod ak. And what will happen to this term? k r raised to k minus 1. K r raised to k minus 1. So you just put k r raised to k minus 1. So your Rn of z minus Rn of w divided by modulus of Rn of z minus Rn of w divided by z minus w is less than or equal to sigma k is equal to n plus 1 to infinity. Modulus of ak just substitute. ആ ടേം സെപ്പറേറ്റ് ആയി എടുത്ത് ചെയ്തു, അത് ഇവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു എന്ന് മാത്രം. ഇവിടെ നമുക്ക് ഇതല്ലേ കിട്ടിയിട്ടുണ്ടായിരുന്നത്. അപ്പോൾ Rn of z മൈനസ് Rn of w എന്താണെന്ന് നമുക്കറിയാം, ഇത് വെച്ചിട്ട് നമുക്ക് കിട്ടി. അതിനുശേഷം അതിനെ മാറ്റി, ഈ ടേമിനെ, അത് സമ്മേഷനിൽ ഈ ടേമിനെ മാത്രം മാറ്റി, അത് ജസ്റ്റ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു എന്ന് മാത്രം. അത്രമാത്രമേ ചെയ്തിട്ടുള്ളൂ, വേറെ കാര്യമായിട്ടൊന്നും അവിടെ ചെയ്തിട്ടില്ല. സിഗ്മ കെ ഈസ് ഈക്വൽ ടു n plus 1 to infinity mod a k r raised to k minus 1. What about k r raised to k minus 1? Summation k r raised to k minus 1. What about that sum? Your small letter r is strictly less than r. Small letter r is strictly less than r. Okay, small letter r is strictly less than r. So what will happen to this sum? What will happen to this sum? So, modulus of r is strictly less than r, capital letter R, and r is the radius of convergence. So what will happen to the sum? K r raised to k minus 1. K r raised to k minus 1. Capital letter R is strictly less than infinity. Capital letter R is greater than 0, and R is the radius of convergence. R is the radius of convergence, and you consider an open ball with a radius this R. Okay, and your small letter r is strictly less than this r. So what about this summation? This k r raised to k minus 1. This series also converges. That means this sum is also less than infinity. This sum is less than infinity means this series converges. When will we can say that a series is convergent? We can say that a series converges if given epsilon greater than 0, there exists a positive integer. So here our aim is to show that modulus of f of z minus f of w divided by z minus w minus g of w is less than epsilon. That means we need to show that f of z is differentiable at this point w, and f dash of w is of this form. Okay, so you need to prove that this limit z tends to w, f of z minus f of w divided by z minus w is equal to g of w. So how we will show that the limit is equal to g of w? Normal definition, given epsilon greater than 0. So you need to show that this is less than epsilon for some positive integer n greater or equal to something. So here you connect these terms with the sum of 3 terms, and we take one term from the sum. Rn of z minus. So we choose, instead of epsilon, we choose epsilon by 3. Now your Rn of z is Rn of z minus Rn of w divided by z minus w is less than this, and this is less than infinity. That means this series is convergent. Okay, that means this series is convergent means this term modulus of Rn of z minus Rn of w divided by z minus w is less than some epsilon by 3. Why we take epsilon by 3? Because here there are 3 terms, this one and this. So now you are considering just this term. Our aim is to show that this limit exists. Okay, so Rn of z minus Rn of w divided by z minus w is less than epsilon by 3 for every integer. For n greater than or equal to, you just choose some n1. Given epsilon greater than 0, there exists a positive integer n1 such that for every smaller n greater or equal to n1, modulus of Rn of z minus Rn of w divided by z minus w is less than epsilon by 3. Is it clear to you? Yeah, yes. And now we are moving to the, so third term നമ്മൾ ചെയ്തു കഴിഞ്ഞു. What about this term? Sn dash